Okay, grade 9, chapter 7.2 in your book on multiplying monomials by binomials, which is really strange because I just had my grade 8s in here and we're working on distributive property in algebra. And in algebra, they're learning how to do 2 bracket x plus 1 equals 6. And they're realizing they have two x's and two ones, which would expand to become 2x plus 2 equals 6. And then, of course, you would just solve it with algebra skills of subtracting 2 from both sides, etc., etc. So with the first couple show you notice is calculate each product. And there are three methods that you can use to calculate this. And I know you don't have this in your notes because I'm giving it to you now in the video. And the three methods are modeling using area model, modeling using algebra model, algebra model, and modeling and solving using distributive property. So real quick, I'm going to do all three for the first one, and you're going to see how I can use all three methods to calculate what the product or what the multiplication is of 2x multiplied by x plus 3. So with the area model, what it basically says is you know that an area of a rectangle is length times width. And if I think about the monomial as being this here, 2x, then I can think of the width as being x plus 3. And the product of x plus 3 and 2x will be what, or the area of this particular rectangle will be the same as the product of the monomial 2x multiplied by the binomial x minus 3. However, what the book does is it says, well, instead of doing a monomial times a binomial, I'm going to break up this length into x from here to here is going to be the distance of x, and from here to here is going to be the distance of 3. And what I'm really going to do is multiply a monomial 2x by x to get this area here, which we'll call a red box. And then I'm going to multiply 2x by 3 to get the green box. And together, that will be the sum of those two will be the area of the entire box, which is the product of 2x and x plus 3. So 2x multiplied by x is the same thing as 2x squared. So the area of that particular box is 2x squared. And over here we have 2x multiplied by 3, or 6x is the area of the green box. So therefore, 2x squared and 6x together are the same as the product of 2x times x plus 3. So therefore, 2x multiplied by x plus 3 is equal to 2x squared plus 6x. And the second question, or the second type of method we can use is called the algebra model. And what we do is we still use a rectangle, except this time our length and our width are going to be put onto a grid. And it doesn't matter which way you do it, but I'm going to put algebra tiles, which are these are the x's. There's an x there. There's an x there. And the width is going to be an x, which is a positive x, and a positive 3, which is 1, 2, 3. Positive 1, 2, 3. And if I complete this thing by connecting all of the lines where they go, and I think about what this is a positive x times a positive x, which makes these positive x squared tiles. And this is a positive 1 times a positive x, make these positives. What I end up having here is these two tiles are 2x squared tiles, and these ones in here are all positive x's, so positive 6x. And I get the same answer I did with the area model, except I'm using algebra tiles instead of numbers and letters, variables and numbers, excuse me. And the last way we can solve it is by using what we call distributive property. So 2x multiplied by x plus 3. What distributive property told us, if we have any polynomial or any term with more than any polynomial with more than one term, each of those terms must be multiplied by 2x. So if I think about that first one, it's going to be 2x multiplied by x, which we said before was 2x squared. We see it actually right over here. The exact same procedure right there. And the second one, 2x multiplied by 3, will be a positive 6x, which again we have right here. And when I combine those together, I end up with the answer of 2x squared plus 6x. And all three of them give me the exact same. So that's the three methods we use to multiply monomials by any polynomial. In this case, we did binomials, but you can do a trinomial, or you can do a 20-term polynomial if you want. One of the things that some of my students get confused about is once they get down to here, can I add those two together? And the answer is you can't simplify that binomial any further, because in Chapter 5 you learned in order to add two terms together they must be like terms. And in order to be a like term they have to have the same variable and the same exponent. So we can't combine those two, so we have to leave it as an unsimplified or undefined binomial, which we don't know the value of x for. So the first question you didn't have to do said Mahmoud used the following method to expand the expression. He said, well, I'm going to multiply 5x by 2x plus 1, and I'm going to get 10x plus 1. Show that Mahmoud's solution is incorrect. Well, there's three ways you could do it. You could use the area model, you can use the algebra tile model, or you can use expansion. I'm going to choose the easiest one, which in my humble opinion is expansion. So I'm going to use distributive property to expand it and say, well, 5x multiplied by 2x is 10x squared, which you got correct. For the next one, 5x multiplied by 1 is not 1, it's a positive 5x. So what you could say is, what did he do wrong? Well, he only multiplied the first term in the polynomial by 5x and not the second term. Sorry, I confused my students because that question wasn't on their sheet. But now we have question 4 in your textbook, which says what multiplication statement is represented by each model, area model. So again, this is just like the first show you know we did. So it really is the monomial, 3x, multiplied by the binomial, which is 2x. This is a positive 4, which means we're going to use that plus 4 to create that binomial. Now you could also have said 2x plus 4 in brackets multiplied by 3x. But if you put your monomial first, you don't need the brackets around it, so it's a little prettier. And I always like to say, if you have a monomial times a polynomial, put your monomial first because it looks lovely. And if I think about the area of each of these parts, 3x times 2x would be 6x squared, and 3x times 4 is 12x. So therefore, the product of those two equals 6x squared and a plus 12x or a positive 12x. The second example, the monomial multiplied by your binomial is 3x plus 3.6, because that's a positive 3.6. 4k times 3k is 12k squared. 12k squared. And 4k times 3.6, well, 4 times 3 is 12, and 4 times decimal 6 is 2.4, so that's 14.4k. And if you don't know how to multiply with decimals, just take your calculator and go, what's 4 multiplied by 3.6? And it'll still tell you 14.4k. That's plus 14.4k is your solution. And you can't add those terms together because they're not like terms. And finally, your last question, monomial is k. Your binomial is 3.2k plus 5.1. So 3.2k times k is 3.2k squared, because k times k, we know we can simplify it into a power of k squared, or exponent of 2. And 5.1 times k is simply 5.1k. It's the product of a coefficient and a variable. So therefore is equal to 3.2k plus k squared plus 5.1k. Question 5 says expand this expression using an area model. So now we are not given the picture, but we still draw the area model. Put your monomial, in this case it's 4r, on your side by itself. And then your composite side, or the one that's made up of two different lengths, is going to be 3.2r for that, and a positive 1 for that. Inside each of those, you're going to have 12.8, which is 3.2 times 4 is 12.8. R times r is r squared. And 4r times 1, or anything times 1, is still itself, so 4r. And therefore, the solution will be 12.8 r squared plus 4r is equal to the product of 3.2r plus 1 times 4r. That's a lot of writing, but you get the idea. Just proving that you knew what you just solved. And you could do it backwards, actually, would be better. And your next question, using an area model. The nice thing about the area model that a algebra tile model can't do is you can't have decimal coefficients or decimal constants in an algebra tile model. It lends itself much better to an area model because you can't make a fraction of an algebra tile. So here, my monomial is going to be half a. My binomial is going to be 3a for that length and 6 for this length. If I think about the parts, this will be a half times 3, which is 1.5. And then a times a will be a squared. So 3 times a half is 1.5, or 1.5 a squared. And a half a times 6 is going to be 3a. And therefore, 1/2 a multiplied by 3a plus 6 is equal to 1.5 a squared plus 3a. Faith, who is one of my more brilliant students, said, Mr. McDonald, what if I put 1.5 a squared instead? That is completely okay. The only reason why you shouldn't do it is if your question was originally a fraction, you should always keep it in fractions, right? Is your answer wrong? No, it's just you should keep it in whatever form was given. In question 9, it says determine the multiplication statement shown by the algebra tile. So since it's giving you the entire thing, this is your monomial, because I know that's just one term. It's negative 3x multiplied by your binomial, which is 2x plus 2, should equal the area, which is negative 6x squared. We see them right here, minus 6x. And if we double check our work with expansion, we should see that that still works out to be the same answer. It's a little messy up here. Take that away. Okay. The second question, B, the monomial is 3x multiplied by the binomial, which is negative 2x minus 1. And when I look at the area model, it's negative 6x squared again. This time it's negative 3x. Okay, negative 3x. And your last one, C, your monomial is negative x, right here, multiplied by x plus 4, which is your polynomial up here, so length and width, will equal the area of negative x squared minus 4x. And if we expand it, we would see that we do get that. Okay. Any questions so far? We're good? Question number 10 says use algebra tiles. So I'm going to draw my little grid, my length and my width using the grid. My monomial, I think I'm going to put my monomial down here this time. So 1x, 2x, 3x. It doesn't matter if you put your 3x in the other length. It does not matter. And it's going to be an x. Well, that's a bad x. It's a little bit longer than the other x's. Make it a little shorter. Try and keep them so they make squares when I make them. Minus 5, minus 1, minus 2, minus 3, minus 4, minus 5. So there we have 3x as the width and x minus 5 as the length, or whatever you want to think of it as. Shade in the grid by completing all of the lines here. And then determine whether all of those are positives or negatives. Since this is a positive x and a positive x, these should be positive x squareds. So I'm just going to put an x squared in each of those because they're all positive x squareds. And since this is a negative 1 times a positive x, those are all going to be negative x's. So my solution will be 3x squareds minus 15x's. And that's what x minus 5 multiplied by 3x will give us. And in the second example, I'll use black here. Let's make our, let's go down this way again. So 2x will be 1x, 2x, multiplied by negative 2x plus 3. This is not the best model I've ever done, but whatever. My board seems to be uncalibrated right now. So complete these lines here. Ask yourself whether those are positive x squareds or negatives. Since it's a positive x and a negative x, those are going to be negative x squareds. And since it's a positive 1 and a positive x, those are going to be positive x's. Just going to shade them in. And therefore, the solution to what is 2x multiplied by negative 2x is going to be negative 4x squareds and plus 6x's. Your next one just says expand using the distributive property. So if I were you, I'd probably just draw arrows in here and say, what's 2x times 3x? It's 6x squared. What's 2x times minus 1? It's negative 2x. What's 3p times 2p and 3p times 0.8? I wish it was 2p. 2p. So 3p times 2p is 6p squared. And 3p times 0.8 is negative 2.4p. Multiply those two by this. Half of 7 is going to be 3.5 m. So half multiplied by 7 is 3.5, and m just stays with itself. And half of negative 12 is negative 6 m squared. Now, some people feel compelled to reorganize those two terms in descending degree of terms, meaning you put your negative 6m squared first and then your 3.5m second. It's up to you. I would just keep it like that because on a test I'm looking for this answer. I don't want you to rearrange them unless I state rearrange them. And finally, the last one, half an r multiplied by negative 1r is negative a half r squared. Now remember, a negative half r squared, now I don't want to really confuse people, but a negative half r squared means a negative half multiplied by r squared. So a negative half multiplied by r squared would give me a negative r squared over 2. So technically, I could write negative half r squared like that if I wanted to, plus 2r. And your second last one, 8.2 multiplied by 2n is 16.4n minus 57.4. The last one is the trinomial multiplied by the monomial. You need 3 arrows for this one. 1, 2, and 3. 3x times x is 3x squared. 3x times 2y. What is 3x times 2y? Well, 3 times 2 is 6. And x times y, I can't multiply it in exponential form because they're not the same, but I could keep it as x times y, which means my answer is 6xy. And 3x times 4 is going to be a positive 12x. None of those are like terms, so therefore I can't gather them. It remains as a unsimplified trinomial. Next question says, if a rectangular button blanket has a width of 3x and a length of 4x minus 3, what is an expanded expression for the area of the blanket? Well, then you had to know that length times width was the area. My monomial will be 3x. My width will be the binomial. An expanded expression means you put these arrows in and determine what the actual area would be, which means it would be 12x squared minus 9x. That's your answer for A. And it says, what is a simplified expression for the perimeter of the blanket? And therefore, we know that perimeter of a rectangle is 2 lengths and 2 widths. If I wanted to measure the distance around a rectangle, I would add 2 lengths together and 2 widths together. That would be the entire distance around the entire blanket or button blanket. So therefore, I have 2 4x minus 3 lengths, and I have 2 3x's. And those combined will end up being the perimeter of the entire blanket. So I have 8x minus 6 here when I expand that, plus 6 more x. And now here, as my good friend Cole would say, I have a trinomial. But we know that we can gather like terms because of those 3 terms that are remaining, 2 of them are like terms, the 8x and the 6x. So my final answer is the perimeter is equal to 14x minus 6. Question 15, Lee decided to build a shed on a square concrete slab. The problem with this question is this concrete slab right here does not look like a square, but it is. So because it's a square, this distance is W, and this distance here is W as well, okay, because it's a square. The shed has the same width as the slab, so this shed here is also W here. What is an expression for the area of the shed? So essentially, the shed's footprint, if I was to look through the shed, what is the area that the shed is sitting on. So for this, we need to figure out what is the distance from here to here. And if I just take a straight line and say this distance from here, this distance from dot to dot, which in this one will be dot to dot from here, this distance here we have defined it as 2 meters. And the distance from red dot to red dot, or the distance from here to here, is W. So this whole distance is W. So how would I define this distance, and I'll use green dot to green dot, from green dot to green dot? The answer is, that question mark is W minus the 2 meters, okay? So therefore, the distance from what would be green dot to green dot is going to be W minus 2. So when I erase this all here, this is W, this is W minus 2. Therefore, the area of the shed will be W minus, or multiplied by W minus 2, which would be W squared minus 2W. So the area of the shed, as an expression, will be W squared minus 2W. If the width W is actually 4 meters, what is the area of the shed? Well, the simplest way to do it would be just to take the W here and change it to 4. And then the W minus 2 will be 4 minus 2, which will be 2. And therefore, the area of the shed would be 4 times 2, which is 8. So that would be the easiest way to say for B, the area equals 8 meters squared. However, I'm going to make it more complicated than it needs to be, and I'm going to substitute 4 into my formula of area equals W squared minus 2W. 4 squared is 16, 2 times 4 is 8, and 16 minus 8 still gives me the same area of 8 meters squared. And the last question that we did says, the basketball court for Jeux de la Francophonie is 5.5 meters longer than 1.5 times its width. So the first strategy all good math students will do is when you're given a story problem, if you can draw what the words are describing, it'll make it much easier. So the first thing you should do is, the width is W. And if the length of this basketball court is 5.5 meters longer than 1.5 times its width, well, 1.5 times its width will look like this, 1.5 W, or 1.5 W multiplied by W, plus an additional 5.5 meters. So the first thing you needed to do is be able to draw that based on the words, which was tough. And then A says, what is an expression for the area of a basketball court? So the area, same thing as all the other rectangles, is length times width, or W multiplied by 1.5 W plus 5.5, which when I expand it with distributive property, will be 1.5 W squared plus 5.5 W. And therefore, the area is that. Okay, that's A. Now B says if the length of the court is 28 meters, what is the area of the basketball court? Well, this is a little tricky. This is interesting, because if I know this is 28, the area is really 28 times W, but I need to know what W is. So since this length here is the same as this length here, I'm going to use algebra to say that 1.5 W plus 5.5 is the same thing as 28. And what I've done here is I've created a two-step algebraic equation that when I solve for it, I will know what W is. And once I know what W is, it's going to be that number multiplied by 28 as the area of the basketball court. So given this length here, which is algebraically expressed as this, is defined as being 28 meters, I'm going to subtract the constant from both sides and get 1.5 W equals 22.5. Divide both sides by the coefficient, so divide both sides by 1.5, and W will equal whatever 22.5 divided by 1.5 is, which is 15. But wait, I'm not done. I've solved for W, which means I now know that the width is not W anymore. It's 15. And the area of the basketball court will be length times width, or 28 times 15, which is 280, and 140, which is 420, or 420 meters squared. So your answer for B is 420 meters squared.